you all to the next topic on realization of current division rule through a new online simulation tool called TinkerCAD. So the circuit that we're going to implement today is shown here where we have two resistors that are connected in parallel where their values R1 is given as 10 kilo ohms and R2 is given as 5 kilo ohms and the power supply voltage value is given as 5 volts. So we will also verify theoretically whether the simulation values are going to match with the calculated theory values. So now coming for the circuit and the theoretical calculation before we move on for the simulation part. To proceed with the current division rule and to obtain the currents across each resistors R1 and R2, we need to first identify the total current through the circuit that is flowing inside the circuit. So that's what we have to do. For that, first let us estimate the equivalent resistance. Since both the resistors are connected in parallel, we write the equivalent resistance formula as R1 R2 divided by R1 plus R2. We take the given values, identify R equivalent value, which is 3.3 kilo ohms. And by Ohm's law, we know that I is equal to V by R. So the total voltage for the circuit is given as 5 volt. And the total resistance that we have identified from the equivalent value, which is 3.3 kilo ohms. And the final current that is flowing through the circuit, this capital I, we have finally obtained as 1.5 milliamps. Now, once we know the total current in the circuit, we can understand the current that is divided or the current across each resistor. Since this is a parallel circuit, voltage remains constant and the current actually divides. So whenever we have parallel resistance, our current divides. So that is what we are going to actually see as I1 is equal to the opposite resistance. So usually the formula that we write for the current division rule is, if you're going to measure across R1 the current, then we need to consider the opposite branch resistance. So here the opposite branch resistance is R2 divided by the total resistance R1 plus R2. Here people misunderstand that instead of total resistance, they write the equivalent resistance value. As per current division rule, we need to write the total resistance, that is sum of all the resistance that are available, whether it is series connected or parallel connection. Okay. So sum of the resistance, which will give you R1 plus R2 into the total current I. Similarly, if you have to measure current across R2, I2, then it should be measured the opposite resistance, which is the opposite branch resistance is R1 divided by the total resistance into the capital I. So once I've substituted all the values that are given, because we know R1, R2 and the total current also we have identified, based on that, I have calculated the theoretical values of I1, which is across R1 as 500 microamps and I2 across R2 as 1000 microamps. Now let us proceed to the TinkerCAD simulation tool. First, I will just give a very brief introduction on TinkerCAD simulation tool, how to register and all. And then it's as simple as any online simulation tool. We can just realize this circuit in TinkerCAD. Once you start typing in your Google search box as TinkerCAD, it will automatically show you the first link. So just click on that. This will navigate to the actual TinkerCAD website. So this is actually very simple to realize, where when you're going to do your simulations and other LT spies and multisim and all, you will not have the physical realization feeling of any resistors and transistors. Whatever you're going to see here, they are going to appear as such that you do it in your physical lab. It's not like you're going to use the symbols of any of the electronic components. Here, it's the physical, or you call it as a virtual lab components, electronic components that are actually available in TinkerCAD. And that's a great advantage here, where students like you who are studying in the pandemic situation, they find it very difficult to actually understand or visually realize how the transistors, resistors will look like. So in such a case, TinkerCAD provides you much amount of opportunities to explore all the electronic components, and you can design or build any circuit and do all the analysis with respect to TinkerCAD. So now, if you're a new to TinkerCAD, then just go to join now. Since I have my own account, I just give it a sign in. Those who don't have, just go click on join TinkerCAD. You can just simply log in with your Google account. So this will navigate to, so once you sign in, automatically it will take you to the home page of your login where it will show you your Google account's name here. And you can actually realize 3D designs, circuits using code blocks and all. And we are interested in designing the circuits here. So let us just go to create a new circuit. And the circuit that we are interested in is two resistors that are connected in parallel. So before that, we'll just name the TinkerCAD project name, which is, let me just keep it as current division rule. And we are, you can see here that there are components that are available, and and then you can also add some notes here, and you can change the wire colors from black, red, and all those things, and the type of wires can also be changed, but we usually keep it as normal. And the components that you want, you can select it either from the available one, or if you want to just search and find out whether that particular component is available, you can just give it a search here. Since we are interested in designing a circuit with two resistors that are connected in parallel, I'm just going to pick and drop here. So just pick this and drop here. So whenever I leave that resistor here, it will automatically ask you to name the resistor. You can even just name this as R2. And this one, if you click on the resistor, it will show you to name it again. So our concern is to keep this as 10 kilo ohm. So we are just fixing the resistance values. And here I'm interested in having it as 5 kilo ohms. You can even change this value to ranging from ohms to pico ohms and also to giga ohms. So here we are interested in 5 kilo ohms. So I'm just fixing that. Now we have two resistors that are connected in parallel. Now we need to just fix the power supply. So just type power space supply. It will automatically show this. So just pick and place it here. And then we need to fix this. You can even name this as power supply. And then 5 volt is mandatory because that is what is given in our circuit. And current we cannot make it to 0, otherwise the circuit won't work. So we just keep it as a minimum one as 1 milliamps. And then we need multimeters actually to measure the current across each resistor. So just if you type that, that will also come again. And you need two multimeters. So let me just place two multimeters to measure currents. But if you click these multimeters, you know the modes. You can just vary to show the current or to measure the voltage or to measure the resistance across this resistance value. So all these are possible, but our interest is to measure the current across the resistor. So I just set it to ampere range, and you can also observe that when I change these modes, the knobs are also changing. Okay, so I'll just change it to ampere range. You can just observe that ampere is selected. And then similar thing, we need to do it here for the next multimeter. So that also I'm going to change it to ampere range. Fine. Now what else we need? We have all the components here. Now we need to just make the wirings properly. So for the wiring, we start with the red color wiring. Usually that is what we do it in the physical lab session also. So to start with, connect the positive terminal of your power supply to one end of your resistor. And then since these two resistors are connected in parallel, we start again with the one end of the resistor, and just you can just click on your mouse so that it bends properly, and you can see beautiful connections. Otherwise, it will just take you to a straight line from here to here. Okay, so just wherever you want a bend, just click it on your mouse. Fine. Now the other end of the resistors have to be connected to the multimeters because we need to measure, no? Across this only we need to measure the current. So we are just connecting the other terminal to the multimeter. Again, this one to the multimeter. So you can even just drag here to make your lines perfectly look. And then we need to connect all the ground connections here. So just for the ground, we use usually black color. So I've just selected that. Click on this and then join the black colors, negative terminals of your multimeters. So this has to be again connected to your other negative terminal. So all the negatives are connected now. So now just everything is over. So what else I would like to tell you is we're not aware of the resistors here. So someone sees the circuit, they should be able to see what is the value of the resistor. Unless they click on this and identify what resistance it is not visible to the user. So what is the advantage here in TinkerCAD is you can just go to the nodes tool here. So just click on that. It will just you can just place it anywhere here. So first I'm just going to name the circuit because it's my circuit. So it's always very easy to name and do your notes here in TinkerCAD. So it will just give the identification here that it is whose circuit. And then what we can do is just click on that again. You can insert n number of nodes here. So this one is your total voltage, which is 5 volt. Okay, and then we have our resistance. So this we need to name. Again, we have to pick up this nodes here. Just click on that. You can just type it as R1 equal to 10 kilo ohm. Fine. So if you want to copy it from your Word pad or your Word document, you can insert even the symbol here. So here the symbol insertion for the nodes is not available. So I've just written it as kilo ohms. So now again, similarly for your R2, we need to just name that. We know that it is 5 kilo ohm. Fine, just drag this, you can just place it anywhere. So we are just placing it near the resistance R2. You can even say, see the color changing. So for 10 kilo ohm, the color codes for this particular resistor is varying. And for the 5 kilo ohm also, you can see how the color codes have been changed. You can even verify once you know the color coding of each of the resistors. Based on the table, you can just verify whether these color codes are matching with 10 kilo ohms and 5 kilo ohms. Fine. So now, suppose if your circuit has gone like this, you can just click on this center zoom button so that it fits properly into your window. And then this one, let us just name this one as I1 because we are going to measure I1 here in this multimeter. And then we have I2. So once all these namings are fine, it looks very clear so that everybody understand what is there in the circuit. So now just give start simulation. You can just observe what are all the values that you have. Here in the power supply, you can see that it is on. So before simulation, it was off actually. And here you have voltage control and current control knobs. Voltage control knob varying from 0 to 30 volt, which means you can vary from 0 to 30 volt. But as per the question, we have set it to 5 volt. And similar to your current values also, that also you can change from 0 to 5 amperes. And you can observe here your voltage source, the power supply is with 5 volt and you are given with the two resistors that are connected in parallel and there will be voltage drop across these things and we can measure the current, total current through the circuit, which we have done the theoretical calculation by using Ohm's law after calculating the equivalent resistance with R1, R2 and we have obtained theoretically also 1.5 milliamps. So the theoretical value goes well with your simulation value. And also if you measure the current I1 across your R1 We have actually got the same 500 microamps in the theoretical calculation. And I2 also, it is much similar to the theoretical calculation where across R2 we have got 1000 microamps. So this is how we try to do a circuit analysis in TinkerCAD. So here I have just shown a simple demo of a current division rule in a parallel R circuit. Okay, so now the same thing we can just see how it can be implemented in a breadboard. Let me just select the component here as breadboard. So you will have different versions. You can just choose breadboard small and pick it place here. And the other components that we require is actually we need two resistors. So once you connect it in the breadboard, you know the breadboard rules that all these positive are connected together. So if you just bring the lines there, no, if you bring your mouse cursor there, it will show you what are the lines that are connected. So all these minus are grounded, all these positive terminals are grounded. And if you bring it here, all these F to J and all these A to E, all these terminals are connected. And similarly here also all the negative terminals are connected and all the positive terminals are connected. This is a basic rule in a breadboard. And I've just inserted my resistor here. So one end at my F and the other end just connected to D. And then I pick up another resistor and I place it somewhere here. And since they are parallel, I'm just placing it here. Okay. So now we need to set the resistance value. Just click on that the same way. You can even name it here as R1, which is 10 kilo ohm. Sorry. And then we have R2. Just click on that. It's going to be R2 and that is 5 kilo ohm. Fine. And then we need power supply. So that we have taken and we will set it as PS 5 volt and 1 amp current. That is the minimum that you can set here. Afterwards, it will change it to the total current in the circuit. Because once you make the connections and start the simulation, all the voltage drops and according to Ohm's law, the final current through the circuit can be estimated. So that is being done actually in the simulation also. And then what else we need? We need multimeters. So just type multimeters again. So just take your, and let me just place it here. And then I have to measure ampere range. So I select the ampere. And then again, I need a multimeter here. And again, that also has to be set to ampere range. Okay. So here I've just made my nodes to be not visible here. So if I just toggle it here, it will show me all my previous nodes. So this I can just drag it and keep it here to measure I1, to measure I2, and this is my R1. So let me just place it here to avoid confusions in the wiring. So this is my R2 and this is going to be my 5 volt and this is the person who is doing the simulation. And one more note that you can give here is this is your breadboard. Fine. Now the left out thing is what we need to do is our connections. So let me just start my red color connections. So let me just first power the breadboard here with the positive supply. I'm just connected. I'm going to connect it anywhere because all these are shorted. And then this positive terminal, this terminal, one end of the terminal of the resistor has to again come here. And similar to that, the other end of the next resistor has to come somewhere here. Now all these lines are shorted, so they are all connected to the positive terminal of your power supply. So now the other end of the terminal with which we are going to measure actually what is the current across this resistor. So all these F to J are at same point. Now they are all shorted. So I can just take from anywhere the connections actually. So I just bring it here. I just connect it to, yeah, it will automatically pass there. From there again, you need to just take one more wiring and just give a bend here. Just click on the mouse, connect it to the positive terminal of your multimeter. And then again, the same thing, we need to start for the next terminal of the resistor. Just start here do a break here and then give another wiring. Just click on the square box. Only then the wiring comes perfectly. So just click here to create a bend, and then I just click here to create another bend, and I just connect it to my positive terminal of the next multimeter. And then it's very simple. I need to just connect all the negative terminals. So let me just first give the negative connection to the breadboard. So here I choose black color wire. Just give the negative terminal here. So here I'm just going to place. And then for the negative terminal of the first multimeter, I need to give the connection. So where do I just go and join that? I'm going to join it in that same negative terminal of my power supply because all these are shorted again. So you can just place this terminal anywhere across these lines. And similarly, the negative terminal of this one has to be connected to again the same shorting. Okay, so now I think the wiring connections are also over. Now it's time to just simulate the circuit. Start simulation. It will give you exactly the same thing that we have got in the theoretical calculation, and also it is matching well with the simulation that we have done previously without this breadboard. So you can see I1, the current across R1 is 500 microamps, and R2 across which current I2 is measured, that is 1000 microamps, and the total current in the circuit is again 1.5 milliamps, which were all these values were verified theoretically also. So now we can just stop the simulation, and that's all for today's video, wherein we have just completely analyzed a parallel circuit, wherein which we have analyzed the current division rule and we have tried to understand the design of any circuit in a TinkerCAD online simulation tool. I hope everybody have enjoyed watching this video on TinkerCAD, where we have just simulated a parallel circuit and we have understood theoretically also how current division rule happens. And we have also realized the same thing in the online simulation tool using TinkerCAD. Hope this has cleared many of your doubts on the simulation using TinkerCAD, and definitely this tool has helped many of the students to actually virtualize how the physical, electrical, or electronic components are present in the physical lab sessions. I hope we will meet with another interesting video on the same TinkerCAD, and much more videos are awaiting on basic electronics. Until then, stay safe. Thank you all for watching this video through Electronics Insight channel.